So in this video, we are going to find a rule to find derivatives without having to use the difference quotient. So the difference quotient is also often a very long and tedious process. And so mathematicians discovered a pattern and then came up with rules based on that pattern. And these rules make finding the derivative much easier and faster. So just as a reminder, the derivative is the slope at a point, it's the slope of the tangent line, and these are our notations that we use for the derivative, f prime of x, dy dx, and d dx of f of x. And the process of finding the derivative is called differentiation. So if we look at this, if we did the difference quotient with these, we would find that if we had f of x equals 3x minus 4, the derivative would be 3. And if f of x is 3, the derivative would be 0. And if f of x is x squared, the derivative is 2x. If f of x is x cubed, the derivative was 3x squared. Okay, and x to the fourth, the derivative was 4x cubed. When it was x to the 7, the derivative was 7x to the 6. And when it's 2x cubed, the derivative is 6x squared. So if you pause the video for a minute and see if you can figure out a rule from, if I have this polynomial function, how I find the derivative. And what you should notice is, like, for 3x minus 4, well, we know that's a line and the slope is just 3. So that makes sense that the derivative is 3. When you have f of x equals 3, that's a horizontal line, and so the slope is 0. So that's why the derivative is 0. And if you look at all the other ones, there seemed to be a pattern. The exponent came in front. It became that coefficient in front for all of these. And the new exponent on the derivative is 1 less. So like it was 2, now if we don't write it, it's a 1. When it was 3, then it's a 2, 4, 3, 7, 6. And for this one, they had 6. So if you think about it, what they did is kind of the same thing. They had that 2 there, and then it would have been like, we have the 3 down and then x squared. And then you can multiply 2 times 3 to get 6 because the 2 is multiplied by the x cubed. So this rule is called the power rule. So just in general kind of rules, if it's a linear function where it's mx plus b, the derivative is always just m, whatever the slope is. If it's a constant function, so if you remember, a constant function is always a horizontal line. And for a horizontal line, the slope is always 0, because if you pick 2 points, the y values are the same, and that means when you subtract them, you get 0 in the numerator. And then for any polynomial function, the rule to find the derivative, which is called the power rule, is that we bring the exponent down to the front, to the coefficient, and then we leave the variable x, and then we subtract 1 from the exponent, and that's called the power rule. So let's look at some examples. So if we want to find the derivative f of x equals x to the 8th. So when we do the derivative again, we need to use one of our notations. If it's like a function like f or g or h, we usually put that function and then the apostrophe x. And then when we do this rule, we move the 8 to the front, we bring it down to the front, and we put the variable there, and then we subtract 1 from the variable. So it becomes 8x to the 7th. Now we can also do this when we have x to a power that's a fraction. So if we want to find f prime of x, if f of x equals x to the 3/4, again, we write the notation for our derivative. We bring the exponent down. We leave the variable there, and then we subtract 1 from the exponent. And just be careful with these. These are easy to make a mistake on. So 3/4 minus 1, I mean, you can think of it as a common denominator, it'd be 3/4 minus 4/4. So it's 3/4 x to the negative 1/4. And if you had to simplify this, remembering from kind of like pre-calculus that when you have a negative exponent, you move it to the denominator, and then the exponent becomes positive. And so it'd be like 3 over 4x to the 1/4. So kind of continuing, we can find the derivative of the square root also using that power rule. So you need to first rewrite it. Okay, remember d dx means I want to find the derivative. So I'm going to write it as x to the 1/2. Okay, the square root of x is the same thing as x to the 1/2. And then when we take the derivative with this notation, we just put equals and then find the derivative. So we move the 1/2 in front. We put it as x, and then we are going to subtract 1 from the original exponent. And so that gives us 1/2 x, and then 1/2 minus 1 is to the negative 1/2. Okay. And again, if you change the negative exponent, it moves to the denominator and the exponent becomes positive. And then you could also, if you're changing it back to square roots, you can rewrite that 1/2 as the square root of x. Now, if we want to find dy dx of y equals 6x, you can either remember it's a linear function and the slope is 6, so the derivative is just 6, or, and I should use dy dx because that was the notation they said, or you can still use the power rule. Okay, this is x to the first if we don't write it. So if you think of it using the power rule, you leave the coefficient in front, the 6, you bring down the 1, and then you always multiply those, and then you have x to the 1 minus 1. Okay, and so this gives me 6x to the 0. And remember, anything to the 0 power is 1. So 6 times 1 is 6. Most students get good at just knowing if it's a coefficient times the variable of x to the first power, it just becomes that coefficient. Now, 5 is f of x equals 4 squared. Now, just know, okay, 4 squared is the same thing as just 16. And so this is a constant, and the derivative of a constant is always equal to 0 because it is a horizontal line. This is like y equals 16. So it's a horizontal line, and the slope of a horizontal line is always 0. Okay. So that's the power rule. From now on, unless the question specifically says use the difference quotient or gives you the formula for the definition of derivative and asks you to find it, we will be using the power rule because it saves us a lot of time.